Welcome YouTubers to another episode in my Grammar Hero series. In today's video, I'm going to finish discussing everything you need to know about triangles in order to be successful on the Armed Services Vocational Aptitude battery. That is the ASVAB. Just to recap, this will be the third video I've created about triangles. In two other videos, I talked about the triangle sum theorem as well as the Pythagorean theorem. In today's video, I'm going to cover how to find the perimeter of all triangles, how to find the area of some common triangles, and I'm also going to review some properties of different types of triangles. So all that said, let's go ahead and get started with today's video. Previously I mentioned that all triangles have three sides and three angles, and according to the triangle sum theorem, the three angles always add up to 180 degrees. As I mentioned, I want to discuss some basic properties about triangles. More specifically, I want to discuss basic properties about equilateral triangles, isosceles triangles, and scalene triangles. As we can see, an equilateral triangle is one in which all the sides are equal, and more often than not, that's denoted with bars on each side of the triangle. And in addition to having sides that are all equal, all the angles inside an equilateral triangle are 60 degrees. Similarly, an isosceles triangle is one in which only two sides are equal, notably these two sides, and similarly, they also have two equal angles. Finally, a scalene triangle is one in which no sides are equal and no angles are equal. Okay, so as we'll see in just a few minutes, you can be tested on your knowledge about these very basic principles, and we'll do these ASVAB type questions off to the side in just a minute. So before we do that though, let's talk about how to find the perimeter of any triangle. It's very straightforward and simple. To find the perimeter of any shape, all you do is add up all the sides. To find the perimeter of a triangle, it's no different. You just add up all of its sides. In this case, it's illustrated by the formula A plus B plus C. So for example, if I let A be 5, C be 3, and B be 2, we would just plug those into this formula, and that would be 5 plus 2 plus 3, which would be 5 plus 3 is 8 plus 2 is 10. Okay, so with those things in mind, let's take a look at some ways in which the ASVAB is going to test your knowledge of the principles of triangles. Question 1 says find x, and as you can see, we're given this triangle that has two equal angles as well as two equal sides. In light of that, we know that this is an isosceles triangle, and given that these two sides are equal, to find x, all we have to do is set those two sides equal to each other. After all, they are equal. So that's the setup to solve this one. Now it's just a matter of solving for x. That is, we want to get x equal to something by itself. And in order to do so, we're going to have to rearrange this equation. I'm going to start by adding 5 to both sides. And as I do this problem, I'm not going to skip any steps, given that I don't know the backgrounds of people watching this video. So negative 5 plus 5 crosses out. That leaves you with just 3x on this side equals 2x. 5 plus 5 is 10. Now we're going to move 2x to this other side where the other x is by subtraction. This is going to cross out, leaving you with 2x minus 2x, which is just nothing. 3x minus 2x is just x, leaving you with just 10. So as we can see, in this case, x is equal to 10. Again, that tested your knowledge of the fact that these two sides are equal. All right, let's look at one more ASVAB question. One side of an equilateral triangle is 15 centimeters, therefore its perimeter is what? All right, so if it's helpful, let's make a little diagram. Again, this is an equilateral triangle, so according to what we know about its properties, we know all these sides are going to be equal. So that means if this side is 15 centimeters, this side is 15 centimeters, and this side is also 15 centimeters. And similarly, as I mentioned, to find the perimeter of any shape, including triangles, you simply add up all the sides. And as we can see, we can just plug these values in accordingly. So this would be 15 plus 15 plus 15. 15 plus 15 is 30, plus 15 is 45. Okay, so in short, that's my discussion of finding the perimeter of triangles, as well as some properties of triangles with which you need to be familiar. If you look around on the internet, you'll see that there's a ton of information about triangles. Most of that is not pertinent for the ASVAB. Again, if you watch the 3 videos I've created on triangles and you understand how to solve for those things, you'll be in great shape for the ASVAB. All right, that said, let's move on to the final topic in this video. That is, we're going to find the area of triangles now. And it's pretty straightforward, but that said, there are a few caveats to doing this. And let's start by talking about the formula for finding the area of a triangle. It's one that you have to memorize since you're not allowed to use a formula sheet on the ASVAB. Thankfully, most people know it already. To find the area of a triangle, you take 1/2 of its base times its height. So in other words, the formula for the area of a triangle is 1/2 base times height. Okay? And that said, we have to be mindful of the fact that not all triangles look the same. There are different types of triangles, as we just saw above. Previously, I mentioned that there are right triangles, and those are triangles in which one angle is 90 degrees, denoted by this symbol here. As you can see, the base and height of the triangle in a right triangle are simply outside, namely here and here. And if we take a look at this triangle, we can see that the base is the bottom of the triangle, but the height runs through the middle of the triangle. Okay, so we have to be mindful of that. And in this triangle, which is an obtuse triangle, we can see that the base is here, but the height is now outside the triangle. Okay, so again, in a right triangle, the height is right along the side of the triangle that's closest to the hypotenuse. In this triangle, which is an acute triangle, the height is inside the triangle, and in this triangle, which is an obtuse triangle, the height is outside the triangle. All right, so that said, let's do a practice problem, and I'm going to go ahead and zoom in so we can see exactly what's going on. Yeah, if I ever forget to zoom in on my video, you can always just click full screen mode on YouTube, and you should be able to see them pretty clearly that way. For some of the videos, I have to make the text small given the amount of work I do in them. So, all right, so number 1 says find the area of this triangle. As we can see, it's a right triangle, and so let's start by writing down the formula for finding the area of a triangle. That's area equals 1/2 base times height. And as I mentioned previously, this is going to be your height, and this is going to be your base as well. So all we have to do is plug those two things into this formula. Base is 10, height is 6. Let's work this out. 10 times 6 is 60, so this is 1/2 of 60. Half of 60, we should know, is 30. So this is going to be 30 centimeters squared. Okay? Pretty simple. And when I took the ASVAB, I remember the questions being very simple. All right, let's do another one. Of course, this is a triangle in which the height is inside the triangle, so we know it's an acute triangle. That said, we still use the same formula. Area equals 1/2 base times height. Again, we know that this is going to be our height, and this is going to be our base. So let's go ahead and plug that into the formula. Again, that's 1/2. Base is 8 in this case. Height is going to be 5. It's going to be 1/2 times 8 times 5, which is 40. Half of 40, we should know, is 20. So therefore, the area of this triangle is 20 square feet. All right, pretty simple. Nothing too difficult about this, but we will get to some challenging questions here in a second. And another thing you have to realize is that you're not always going to be given, you're not always going to be asked to find the area of a triangle. In some problems, you're going to be given the area and asked to find the height or its base. And again, that's just a matter of plugging things in the formula and solving for the missing variable. In this case, it says find the height of the triangle, given its area is 39 inches squared. So again, let's start by writing down the formula to find the area of a triangle. It's area equals 1/2 times base times height. And we don't know what its height is, but that said, we know its base is 13, and we know its area, moreover, is 39. So let's plug those things into the formula accordingly. Again, we know its area is 39. 1/2 we just copied down. We know its base is 13, and we don't know what its height is. So in this case, instead of finding the area, we're solving for h, which is a fairly simple thing to do. But let's start by dealing with this. Let's see how we want to start this one. Let's start by getting rid of this fraction, and I'm going to do that by multiplying both sides by 2. This is going to cross out 1/2. 39 times 2, let's do this off to the side. My pen's acting up a little bit. 9 times 2 is 18, carry your 1. 2 times 3 is 6, plus 1 is 7. So this becomes 78 equals 13h. And in case you're relatively new to, in case you haven't seen this in a while, let's take a look at what I just did there. Again, I wanted to get rid of this 1/2. So I multiplied it by 2. And when you multiply 1/2 by 2, you're essentially doing this. You're doing 1/2 times 2. To do this multiplication, we have to place 2 over 1. Then we multiply straight across. 2 times 1 is 2. 2 times 1 is 2. 2 divided by 2 is 1. So this basically says 13h times 1. Anything times 1 is itself. So that's basically what went on right there. So now let's get back to this. Now we're just solving for h. So we're going to divide both sides by 13 as our next step. This is going to cross out. In case you don't know what this is off the top of your head, you can start playing with the numbers. Again, if you thought this was, I don't know what I'm doing there. Sometimes if you don't know what this division is off the top of your head, you have to do multiple iterations of multiplication to figure it out. 3 times 5 is 15, carry the 1. 5 times 1 is 5, plus 1 is 6. So we can see it's not 5. 5's too small. Let's see, 13 times 6. 3 times 6 is 18, carry the 1. 1 times 6 is 6, plus 1 is 7. So we can see 78 divided by 13, or 78 over 13, is going to be 6. So we know 6 equals h. In math, it's customary to write the variable for which you're solving on the left. So in other words, this is h equals 6. Therefore, we know the height is 6 in this case. Okay, so that was that one. Let's do a couple of practice problems. I'm going to do all 4 of these. At this point in the video, I think you know enough to be able to handle these on your own. So in light of that, if you want to pause the video, try to work out these questions on your own, and then resume playing the video to see if you and I come up with the same answer. That would be the best way to get the most out of this video. But that said, let's go ahead and get started with number 1 again. And I'm just going to do one. Let's do all 4 of them. All right, so number 1 says find the area of a triangle. So that's going to be area equals 1/2 base times height. Again, we know our base is 9 and our height is 8. So let's plug those in. Area equals 1/2 base of 9 times 8. Area equals 9 times 8, of course, is 72. So this is 1/2 times 72. And in case you can't do this in your head, let's work it off to the side again. And in case you haven't done this math in a while, let me show you exactly what's going on. This is basically 1/2 times 72, which you can't do. You have to put 1 under 72. 72 divided by 1 is just 72. And then you multiply straight across. So this becomes 72 over 2. Again, that's 1 times 72, which is 72. 2 times 1, which is just 2. Now you have to understand that you can treat all fractions as long division. Notably, you can regard this as 72 divided by 2. So let's go ahead and do the long division if we can't figure out what this is in our head. 2 goes into 7 3 times without going over. 2 times 3 is 6. Subtract 7 minus 6 is 1. Drop down this 2. 2 goes into 12 6 times evenly. 2 times 6 is 12. So we can see there's no remainder. So the area in this case is going to be 36 inches squared, or 36 square inches. Okay, so that was that one. Let's go ahead and move on to number 2. All right, again, it's always a good idea to start by writing down the formula first. And again, area equals 1/2 base times height. In this case, we know the base is 12 and the height is 7. So let's go ahead and plug those things in accordingly. 1/2 12 for the base times 7 for the height. And in case you haven't done this in a while, again, I recommend that you know your times tables up to 15 times 15 or 20 times 20. It's up to you. But that said, we could always work this off to the side if we need to. 2 times 7 is 14. Carry your 1. 7 times 1 is 7 plus 1 is 8. Therefore, we know 12 times 7 is going to be 84. Again, since I showed you what was going on over here, let's just go ahead and go right to this. This is the same as 84 over 2. 2 goes into 8 4 times. 2 goes into 4 2 times. So we know the area of this one is 42 yards squared, or 42 square yards. All right, let's work on number 3 now. All right, as we can see, we have a base right here at 15 and a height of 16. So let's plug those into the area formula, which is area equals 1/2 base times height. 1/2, the base in this case, as I said, was 15. The height was 16. So let's do the division of, or the multiplication of 15 and 16. 16 times 15. 6 times 5 is 30. Carry your 3. 1 times 5 is 5, plus 3 is 8. Add a 0. Since we're starting this number, 1 times 6 is 6. 1 times 1 is 1. Let's add. 0 plus 0 is 0. 8 plus 6 is going to be 14. Carry a 1. 1 plus 1 is 2, so this is going to be area equals 1/2 times 240. And again, this is the same as 240 over 2. 2 goes into 2 1 time, 2 goes into 40 20 times, so this area equals, what measurement is this? This is in centimeters, so this is going to be 120 centimeters squared. Okay, so that was that one. Let's look at number 4 very quickly. And let's get rid of some of this so we can have some space to work with. That should be enough. All right, number 4 says a triangle has an area of 84 square inches and a height of 16 inches. Find its base. Okay, so let's go ahead and do a little drawing. It didn't tell us what type of triangle it was, so I'm just going to draw a nice simple right triangle. We know it has an area of 84 inches squared according to the problem, and a height of 14. And we want to know what its base is, which is right there in the right triangle. Again, we're going to use the area formula to solve this one. Area equals 1/2 times base times height. In this case, we know what A is. It's 84. 1/2. We don't know what its base is, so we're going to leave that as B. And we know its height is 14. To start, I'm going to get rid of this 1/2 by multiplying both sides by 2. This is going to cross out, leaving me with 14b on this side, and 84 times 2 is 4 times 2 is 8. 8 times 2 is 16. So this is 168 equals 14b. Divide both sides by 14. This crosses out, leaving you with just, and let me move down a little bit here. Just leaving you with b on this side. And now we have to do division, in as much as all fractions can be regarded as division. This is 168 divided by 14. Now the question is, how many times does 14 go into 1 without going over? It doesn't, it's too small. How many times does 14 go into 16 without going over? That's 1 time. 1 times 14 is 14. 16 minus 14 is 2. Bring down this 8. How many times does 14 go into 28 without going over? That's 2 times. 14 times 2 is 28. So there's no remainder there. So we can see that the base in this case is 12. Again, in math, it's customary to write the variable for which you're solving on the left. So we can see that this is going to be b, or base equals 12. All right, so let's take a look at 2 more practice problems, and then we'll be done with today's video. In this example, we're being asked to find the area of this right triangle, and we're only given its height as well as its hypotenuse. So before we can use the area formula to figure this one out, we have to recall what we learned in the video where I discussed the Pythagorean theorem. That is, you can find any side of a right triangle by using the Pythagorean theorem, which is a squared plus b squared equals c squared, where a and b refer to the legs of the triangle, and c refers to the hypotenuse of the triangle. Of course, the hypotenuse is easy to identify, given that it's always directly across from the right angle. So in this case, we need to find b, because this is the base and this is the height of this triangle, which we need to plug into the area formula. So we're going to have to make use of the Pythagorean theorem before we can do that. So let's plug in what we have. We don't know what b is, but that said, we know a, which is the other leg of the triangle, is 5. So this is 5 squared plus b, which we don't know, so we'll leave that empty or as is. And the hypotenuse, as I mentioned, is across from the right angle, so that's going to be 13 in this case. Again, we're going to solve for b, which is going to enable us to use the area formula. So let's go ahead and do so. 5 squared is 25 plus b squared equals 13 squared. In the video in which I discussed the Pythagorean theorem, I said you should know your squares from 1 to 20. 13 squared is 169. Again, 13 squared would be the same as 13 times 13, which I'm not going to work out. Now we're just solving for b squared, so we want to get b by itself. So we're going to subtract 25 from both sides. This is going to leave you with b squared equals 169 minus 25. 9 minus 5 is 4. 6 minus 2 is 4. 1 minus nothing is 1. So this is b squared equals 144. Take the square root of both sides, which will cause this square to go away. This will be b equals the square root of 144, which is just 12. right, so we know B is 12. And now that we've found B, we can use the area formula to find the area of this right triangle. Again, area equals 1/2 base times height. We know what those things are. The base is 12, so this is 1/2 times 12, and the height is 5. So area equals 1/2. 12 times 5 is 60. Area equals half of 60, which is 30. And we're not given any measurements, so just 30 units squared. All right, let's do one more. Let's do number 32 and then call it a day. So 32. Again, we're trying to find this area of the triangle, of this right triangle, and we're only given its hypotenuse and one of its legs, notably A. In order to find the area, we need its base as well as its height. So we're going to have to use the Pythagorean theorem first to find B. And then once we get B, we can use the area formula to find its area. So let's start by writing down the Pythagorean theorem. A squared is 6 squared plus B squared. We're trying to solve for that. C is 10, so this is 10 squared. Let's keep working this out. 6 squared is 36 plus B squared equals 100. Again, 10 squared is 100. Subtract 36 from both sides. This crosses out, leaving you with B squared equals 100 minus 36. And let me do that over here so I can do the area right next to it. (100 minus 36). 0 minus 6 we can't do. There's nothing to borrow from here, so we have to come all the way over here and borrow. This becomes 0. This becomes 10. Now we can borrow one more time. This becomes 9. This becomes 10. 10 minus 6 is 4. 9 minus 3 is 6. So B squared equals 64. Take the square root of both sides. This crosses out, leaving you with B equals the square root of 64, which is 8. So we know the base is 8, and the height is 6. So let's go ahead and plug those things into the area formula. Again, area equals 1/2 base times height. We know what those things are, so let's plug them in. Base is 8, height is 6. Area equals 1/2. 8 times 6 is going to be, let's think about that one for a second, 48. Area equals half of 48, which is going to be 24. So the area in this one is going to be just 24 units squared. And I wrote units because they didn't give us a measurement of the side in terms of feet, inches, or anything like that. So that's all there is to today's video. Again, these are some very simple concepts that might be tested on the ASVAB. You'll definitely see a question in which you have to find the area of a triangle. So hopefully you have a good understanding of that now that I've discussed it in this video. If you like the content that I'm creating, by all means subscribe to my channel. By the end of July, I anticipate having more practice tests as well as topics for all our videos for all the topics that will appear in the mathematics knowledge as well as the arithmetic reasoning subtest. As always, you can leave some feedback in the comment section below. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.